Hello, and welcome to this lesson. Today, we're exploring a fundamental concept in programming, the difference between static variables and temporary variables. To understand this, we've set up a simple experiment. We have a program with a single button. When we press this button, we want to count how many times it's been pressed. Inside our program, we've written the exact same counting logic twice. The first counter uses a temporary variable. The second counter uses a static variable. In theory, both should work. Let's run the program and see what happens. I'm going to press the button. Oh, notice that. The static variable correctly counted to 1, but the temporary variable is still at 0. Let's press it again. The static variable is now 2. The temporary one is still 0. And again, 3, 4, 5. The static counter works perfectly while the temporary counter does nothing. So, why is this happening? Even though the code is identical, the type of variable changes everything. Let's break down what's really going on. The temporary variable. Explained. Think of a temporary variable like a temporary Scratchpad. When your program runs, it executes in a very fast loop, or scan. When it's time to run our function, the program gets a fresh, blank sheet of paper, our temporary Scratchpad. When we press the button, the program follows the logic. It takes the current value, which is 0, adds 1, and gets a result of 1. It writes 1 on the Scratchpad. For a very brief moment, the value is 1. But here's the critical part. As soon as the function is finished, and for that single program scan, the program throws the Scratchpad away. The very next scan, it gets a new blank sheet of paper. When we press the button again, it just repeats the process. It starts from 0, adds 1, writes 1 on the sheet, and throws it away. This is why it's called temporary. Its value is not remembered between program scans. The static variable. Explained now, let's look at the static variable. Think of a static variable as a permanent whiteboard. When your program is first loaded, it sets aside a reserved, permanent memory space for this variable. This is its whiteboard, and no other part of the program is allowed to use it. When we press the button, the program goes to this specific whiteboard. It sees the current value, which is 0. It erases the 0 and writes 1. When the function finishes its scan, it does not throw the whiteboard away. The whiteboard stays on the wall with the 1 still on it. The next time the program scans, it goes back to that exact same whiteboard. It sees the 1, erases it, and writes 2. This is why the static variable works. It is called static because it stays in one place and its value is retained or remembered from one scan to the next. Why this matters, the core difference. This concept of remembering data is the key. Temporary variables are fast and memory efficient. They use a shared pool of memory called the local data stack. A function grabs memory when it needs it and releases it as soon as it's done, allowing the next function to reuse that same memory. This is perfect for short-term calculations where you don't need to remember the result, like finding the average of two numbers. Static variables are persistent. They reserve their own private piece of memory and never give it up. This is essential for any logic that needs to track a state over time, like our counter or a timer or tracking an alarm. The FCC versus FBs. This brings us to one of the most important distinctions in this programming environment, the difference between a function or FC and a function block or FB. A function FC by design only has temporary memory. It's just a Scratchpad. It cannot have static variables. This is why you can't use an FC to build a counter that remembers its value. A function block FB is special because it can have static memory. It's a function that comes with its own permanent whiteboard. This whiteboard is what we call a data block, or DB. The data block is the physical memory location where all the static variables for that function block are stored. So when you need to do a simple one-time calculation, use a function FC. But when you need to build something that must remember its state, like a motor, an alarm, or a counter, you must use a function block, FB, with its static variables. To prove this, let's fix our broken code. All I have to do is change our temporary variable to a static variable. Now, when I download and run the program, both counters work perfectly. Summary. To recap, temporary variables are like a Scratchpad. Their values are lost after every program scan. They are perfect for in and out calculations. Their values are retained from one scan to the next. They are essential for tracking any state over time. This difference is the main reason we have both functions FC for simple logic and function blocks FB for complex state-based logic.